Hey guys, welcome back. 6.3 is all about the inverse trig functions, which is now just simply reversing the process we were doing on the unit circle from the 6.2 videos. Now, inverse trig functions, which you should recognize when we did the law of sines and law of cosine solve for an angle, is the sine -1, cosine -1, and then the tangent stuff from right-hand trig, tangent -1 there. Those are the inverse trig functions. More formal notations using the word, or I guess the phrase there, arc, before your sine, cosine, and tangents. Now, the important thing to remember is the idea of the range right here. This is the value you should be getting when you do your inverse sine, inverse cosine, or inverse tangent. Noticing that the range for sine and tangent inverses go from -90 to +90 or -π/2 to +π/2. That means you're looking at quadrant 1 and quadrant 4, but the quadrant 4 is not your 270 to 360, it's the negative quadrant 4. A negative coterminal angle. Whereas inverse cosine goes from 0 to 180 or 0 to pi. Now this is important because when you're asking questions that it directly asks what is the cosine inverse of this, you're not doing anything else with the problem, you need to make sure you're answering in the appropriate quadrant. Positive answers come from quadrant 1. If it's a negative fraction, negative result, then you got to get a quadrant 2 for cosine, or the negative coterminal for quadrant 4 for sine and tangent. There's a trick we can use for the sine and tangent ones to make the negative a little bit easier, and we'll discuss that. Now, it's all based on the unit circle still. All these values are going to be exact values. Your calculator is not going to be used in any way, shape, or form. So what you're looking for is, in quadrant 1 or quadrant 2, where's the cosine value on the unit circle a -1/2? So we're looking for where's the x-coordinate -1/2. Now, if you have this thing memorized, you can pretty much picture the unit circle in your head and recognize, okay, -1/2 is occurring at 120 degrees, or at 2π/3 radians. Both are acceptable. If you're having some issues picturing it in your head, the idea is you need to recognize that if it's a √2/2, that's the middle, that's the π/4 locations. If it's a 1/2 or a √3/2, that's either closest to the x-axis or the y-axis. For cosine, 1/2 is closest to the y-axis, hence the 120, or the π/3 locations. Whereas if it was √3/2 for the cosine, then it's closest to the x-axis, which would be π/6 or the 30-degree locations. So the more of the unit circle you have memorized, the easier these questions are. The less you have memorized, the more challenging these questions do become. Now, if you are allowed to use a calculator, you can just simply type it in, cosine inverse of -1/2. If you're in degrees mode, it will tell you 120. If you're in radians mode, it'll tell you whatever the decimal of 2π/3 is supposed to be. I think it's like 2 point something. I would not use a cosine inverse or sine inverse for an exact value, though, with a calculator in radians mode, because it's not going to give you a nice number to work with. You're better off recognizing in degrees, or again, knowing it based off the unit circle and not actually using the calculator. So √3/2, again, like we just kind of discussed, that's closest to the x-axis. Closest to the x-axis is the 30-degree mark, or the π/6. If it was a negative √3/2, then it'd be on the opposite side, which would be 5π/6 or 150 degrees. So it just depends. Positive is quadrant 1, negative is quadrant 2. And again, if we were more in the middle, then it's the 45 or the π/4s. So that's cosine. Now, as for sine, there's a little trick you can use with the sine inverse and also tangent inverse involving negatives. And it's one of those things we are going to discuss when we get more into Unit 7. We talk about different trig identities. Sine inverse of negative √2/2 is the same thing as negative sine inverse of positive √2/2. We can't do this for cosine, but with both sine and tangent, we can pull the negative outside of it, and it's going to be the exact same result. This is nice because the answer is supposed to be a negative angle if it's the negative quadrant, not a quadrant for positive location like 300 degrees. It would have to be a -60 instead. So this is a little bit easier to recognize the negative angle now. Also, it's easier to see everything based off quadrant 1. √2/2 is the middle. Middle is 45 degrees. So it's -45 degrees or a -π/4. So as long as you know the quadrant 1 location for the sine, you're just doing the negative of it when it's a negative fraction instead. Sine inverse of +1/2. So the sine is the opposite of the x's. They're both in the middle at √2/2, so they're both 45s for that location. Sine of 1/2 is closest to the x, whereas sine with the √3/2 is closest to the y. So in this case, we're closest to the x value, so that's 30 degrees. or again, pi over 6. So that's our sine inverse. Now, tangent inverse is going to require you to be a little more careful. When it's the root 3 over 3 or the root 3 values, you have to recognize which one was which. Now, we got root 3 over 3 when we had a 1/2 over root 3 over 2. Because when you work through that scenario, you get 1/2 times 2 over root 3, where the 2's canceled, then we had to rationalize it. Okay? So we're working with when y is a 1/2, x is a root 3 over 2. Now, same as with sine, we can pull the negative out. So it's negative tangent inverse of positive root 3 over 3. We're seeing y is a 1/2, x is a root 3 over 2. Again, y is closest to the x-axis when it's a 1/2. X is close to the x-axis when it's a root 3 over 2. So this is the 30-degree mark. Or the pi over 6. And again, they're both negatives because it's a negative on the outside there. So we have to recognize tangent inverse of root 3 over 3 is going to be based on 30 degrees. Whereas when we have like tangent inverse of just root 3, that's going to be based on 60 degrees or pi over 3. And again, if it was a negative root 3, then the answer would be negative 60 and negative pi over 3. That negative idea, again, only applies to sine and tangent inverse, though. It does not apply to cosine inverse. So be very careful when applying that particular rule. Now, when tangent is 1, well, you get 1 when everything cancels, implying we have to have a root 2 over 2 and then a root 2 over 2 again. So the negative comes out because it's a tangent inverse of a negative number, so it's now negative tangent inverse of 1. This occurs when they're both root 2 over 2s at 45. So it's negative 45 degrees or negative pi over 4. And again, both answers are perfectly acceptable. I do believe, for my class's purposes, the homework assignment questions and the quiz review sheet are based on radians for the answers. So they would probably say, like, negative pi over 4 if this was a question on the homework. On the quiz, if you say negative 45, I will accept that. All right, again, I'll accept either one. You decide which one you want to give me, but I would accept either one. So that's our straightforward inverse. Now, if we start having a double function here, regular on the outside, inverse on the inside, it's going to create a different type of question. In this scenario, tangent of the cosine inverse, we're actually solving out a right triangle problem. Because cosine inverse of 7 over 9 is going to create some theta value, some angle. So they want to know what is tangent at this angle, this theta. So the best way to do this, especially because 7 over 9 is not on the unit circle in any way, shape, or form, is we're going to draw out a right triangle. How you draw the right triangle does not matter. I'm going to always draw it with this orientation with theta down the bottom corner. You can rotate the triangle around however you want. So you can put theta wherever you want. It's not going to ultimately matter as long as you do the SOHCAHTOA right triangle trig part correctly. Cosine is adjacent over hypotenuse, so the 7 would go here, the 9 would go there. Even if you switch them around, move theta somewhere else, rotate this triangle around whatever you want, it would still be in this kind of orientation. And then the missing side over here is what something we need for tangent, because tangent is opposite over adjacent. So in order to find the x, it's Pythagorean theorem. X squared plus 7 squared equals 9 squared. X squared plus 49 equals 81. X squared is equal to 32, so we square root it. More often than not, you're not going to get a perfect square, so it comes down to can you simplify it. And we can recognize 32 is 16 times 2, and square root of 16 is 4, so we get 4 root 2 for the missing side. So since we're doing tangent of this angle now, it's opposite over adjacent. The final result is 4 root 2 over 7. Since it's possible, since you're more likely not to be getting a radical there, keep in mind, if the radical is in the denominator of this fraction, you set up the tangent or sine or cosine theta, whatever it's going to be, you would still need to rationalize. Just like we had to simplify root 32 to get 4 root 2, you would still need to rationalize if the radical was in the denominator. But the key is you're setting up a right triangle based off the inside inverse trig function, because that's going to create an angle. So you set up the right triangle based off that angle, solve for the missing third side, and then do your right triangle trig for the outside function. So if we have sine of tangent inverse here, so the tangent inverse of the 3/8 is going to create our angle, our theta. So we're looking for sine of theta. So again, I'm going to draw my triangle this way. It doesn't matter how you draw it. Just make sure, based off wherever the angle is, the 3 is opposite, the 8 is adjacent. We obviously have to solve for the hypotenuse. So 3 squared plus 8 squared equals x squared. 9 plus 64 is 73. And when we square root that, 73 is prime. So there's nothing more we can do with that. We can't simplify it in any way. So that's it. So then our sine of the theta, well, sine is opposite over hypotenuse, so it's 3 over root 73, which we can't leave like that. We have to rationalize. That's the timesing root 73 to top and bottom. And we get root 73 over 73, which still can't be reduced. So that's it. It's possible if the number was divisible by 3, you'd have to reduce the 3 with that radical result after rationalizing. Since it's not, we can't really go any further from here. All right, so that's it for the double trig function, regular on the outside, inverse on the inside. We also have the reverse. We have the inverse trig on the outside, regular on the inside. So in a case like this, you're doing the unit circle on the inside, and then the sine inverse, or whatever the inverse trig function of that result. So we got to first figure out what is cosine of negative pi over 6. So cosine of negative pi over 6, again, so the way the negatives work for cosine, and this only works if it's like, cosine of an angle, is that, so the negative was pulled outside for sine and tangent, as we're going to learn when we talk about Unit 7 with the different fundamental identities for trig, the negative actually cancels out. Cosine of negative pi over 6 is equivalent to cosine of pi over 6. Well, cosine of pi over 6 is closest to the x-axis, so it's root 3 over 2. So this becomes the sine inverse of root 3 over 2. Well, that's a positive value. Sine is positive in that first quadrant. Sine is root 3 over 2 closest to the y-axis now, which means that's going to be our 60 degrees, or pi over 3. All right, so again, the negative stuff, if it's sine or tangent, we can pull the negative outside and evaluate it that way. If it's cosine of a negative angle, we can ignore the negative and just do cosine of the positive angle. And that's the negative angle identity, which we will again discuss in 7.1 with the different other trig identities. All right, let's do one more. So we got tangent inverse of sine of negative pi over 2. So again, with sine of negative angles, the negative pulls outside, it doesn't disappear. So sine of pi over 2 is 1, so it becomes a negative 1. So this is tangent inverse of negative 1. Like with sine, tangent pulls the negative outside, so it's negative 1 times the tangent inverse of positive 1. Tangent is positive 1 when they're both root 2 over 2s, which only occurs at 45, so it's negative 45, or at pi over 4, so it's negative pi over 4. And again, all questions involving the inverse trig based on examples 1 through 6, then the 9 and 10 here, degree or radians, entirely up to you which one you give me. Just recognize if you're using the calculator, if the calculator is in degrees mode, it will give you the correct answer in degrees, but if it's in radians, it'll give me the decimal equivalent here. And where you'd need to watch out, if you try typing this in the way it is right now, this has to be in radians mode because the angle given to us is radians mode. If you want to do it all in one step in your calculator and get it in degrees, you have to convert the negative pi over 2 to negative 90 and then do it that way. All right, so each of these questions, while the calculator can do it for you, you do want to make sure you are getting more and more comfortable with the unit circle. It's the kind of thing that going forward, you are going to be expected to be able to do. So make sure you're comfortable with that. All right, so that's it with your different basic angle information. The next 3 sections are all about graphing. We're going to take a look at 2 types of graphs for each section, sine and cosine of 6.4, cosecant and secant for 6.5, and then tangent and cotangent for 6.6. So I'll see you guys next time with those graphs.